How about a model which can produce prompts and outputs to be consumed by other models? I think this is what the future of AI looks like, because we will be using one generic model such as this Octopus version 4 from Nexa AI, and then this Octopus model would be used to generate domain specific prompts for specialized LLMs. Or, in other words, with the help of this Octopus version 4, we can build a graph of various models, and each model would be specialized in its own domain. This model, Octopus version 4 3 billion, is an advanced open source language model with 3 billion parameters, serves as a master node in Nexa AI's envisioned graph of language models. It has been tailored specifically for the MMLU benchmark topics. This model efficiently translates user queries into formats that specialized models can effectively process. We will be installing this model on the local system, and then we will be also generating various prompts for specialized models in the light of that MMLU benchmark. MMLU stands for Massive Multitask Language Understanding, and it's a test designed to measure a text model's multitask accuracy by evaluating models in zero shot and few shot settings. The MMLU benchmark is a diverse set of tests designed to evaluate the understanding and problem solving abilities of language models across multiple domains. And that is what this awesome model is supposed to do. This Octopus version 4 excels at directing these queries to the appropriate specialized model, ensuring precise and effective query handling. Octopus version 4 3 billion is compact, enabling it to operate on smart devices efficiently and swiftly. It accurately maps users' queries to the specialized models using a functional token design, enhancing its precision. Octopus version 4 3 billion assists in converting natural language into a more professional format, improving query description and resulting in more accurate responses. So now let's get it installed on our local system, and then we will test it out on different MMLU tasks in different domains. I am using Ubuntu 22.04 on my local system. I have one GPU card of 16 GB VRAM and my memory is 32 GB. Let me clear my screen. If you haven't already, install this transformers library. If you already have it, make sure to upgrade it. I already have done it, so I'm just going to go straight with model downloading. Now, in order to download the model, first you need to import some of the prerequisites like PyTorch and transformers. So let me quickly do that. First, I'm importing the PyTorch. That is done. Let's also import transformers. And now let's import the time and then also set a random seed just to make sure. And now let's download the model, our Octopus V4. And because I'm using GPU, so that is why I have done the CUDA. I already have downloaded the model, that is why it is so quick, but I think it is not that big. I think 5 to 6 GB, even maybe less, so it should be fairly quick to download. It has already been loaded on my GPU with the shards. Let's also grab the tokenizer. That is done. Now let's first ask it a maybe maths question, and we will see if it is able to select the math model. So this is my prompt in which I'm asking it a math question that tell me the result of derivative of x power 3 when x is 2. Let's also set the input with all the system user and assistant prompt. So basically this is a prompt template in which I am telling this Octopus that you're a router. Below is the query from the users. Please call the correct function and generate the parameters to call the function. So let's set the stage here. Maybe I'll just print it, so all the responses will be below. Let's first send this text to our tokenizer to convert it into tokens. That is done. Let's initialize our generated token IDs array, and now let's grab the output from the model. So I'm just putting it in this loop where I will be generating it. And there are various methods, but I think for this one, this method looks good to me. I'm just grabbing the next token, putting all the tokens in this array which we have just initialized, the generated token IDs one. That is done. And now let's generate the concatenation from there. That is done. And now just break the loop if the token has reached to 32041. So that's more than enough. And that's our loop. You can ignore this warning about flash attention because we are not using it at the moment. And now we can print the response out. Let me make it fit on the screen. Sorry, give me a sec. I'll just do it in real time. There you go. Now you should be able to see it. Let me press this and now I'm going to print it. So remember our prompt was the math one. I'm printing it. So there you go. So Nexa 4 is the math GPT or the math model. And this is a special token which represents that. And if you see, it has converted our simple query into a proper math function. And that is the beauty of this model, is that it is able to convert your natural language prompts into this simple query. So because this model, so in this use case, for example, Nexa_4 is a special token representing the math GPT. The natural math question is converted into a professional math expression to facilitate better understanding by the worker model. Okay, now you can also use the Python main dot function to convert it. But anyway, so let me now try it out with, for example, with another question. So I'm just going to ask it, what is the concept of entropy in thermodynamics? Now this is not a math question. So let's see what sort of model it selects for it. So I'm just going to and put it in the pipeline, similar to what we did earlier. So bear with me while I paste all the commands here. And I'm going to generate the input ID with the tokens. That is done. And now let me quickly set the loop here. So I have put it in the loop. Let's wait for it to generate it. The output, I mean, from the model. Shouldn't take too long. And this time we have asked it about the concept of entropy. So let's see. It shouldn't be selecting the Nexa 4. There you go. This time it has selected chemistry GPT, which is good. So you see, as your prompt changes, it changes the function call to the relevant model. Let's ask it maybe a different question. So this time I'm asking it, describe the theory of evolution. And then I'm again just passing it all the pipeline stuff. So now let me generate the inputs, and I will also put it in the loop and show you. So I have put it in the pipeline. Let's see what sort of model it selects this time. So let me print the response. Give me a sec. I'll grab the command. There you go. This time it has given us the Nexa 2, which is the BioGPT. So this is how easy and this Octopus V4 works as a router. On the basis of the prompt, it selects the relevant model. And then of course you can just chain it to actually call that model, the worker model, whatever that is. And there could be any which you would select. For example, for the general purpose, you could go with Llama, and I have another video where I go into that domain specific models. But the crux of the matter is that Octopus V4 is so intelligent that it generates the relevant prompt and the relevant function call for the relevant specialized domain model. So that's it, guys. I hope that it was useful. I will drop the link to this model card in video description. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network, as it helps a lot. Thanks for watching.